So verifying trig identities. This is one of the pain processes of trig when you learn it to begin with. The general idea that I want to remind you of is that even though in the proof you cannot move across the equal sign, we can when we are working in secret.
Yeah, that's the notes behind the podium.
Yeah, so we're giving a speech.
Or under the podium.
Under the podium, whatever. Yeah. The audience doesn't see it.
Yeah.
Right, so we're giving a speech that doesn't cross the equals. But our notes can. Now, maybe this makes sense to the viewer, maybe it doesn't. But
yeah, the viewer will find out as soon as you go through it.
Anyway, so let's try the first one. The question is 1 minus sine squared t times 1 plus tangent squared t, is this equal to 1? And so we're saying that we cannot cross to the right there.
Yeah. Oh, never mind. Or should I say something?
You want me to ready to go? You want me to do this, or are you you have a suggestion, or?
Yeah, I was just gonna say that like 1 minus sine squared is cosine squared.
Okay, easy stuff.
And we know that tangent is tangent squared, it will be sine squared t over cosine squared t, and 1.
Now I distribute cosine.
Yeah, and but I mean the other side. 1 is just cosine squared t plus sine squared t.
Ah, okay. So now in our minds,
under the podium, exactly.
Yeah, secretly we're expecting that the right-hand side will show up as cosine squared plus sine squared.
Yeah.
Okay, but all of this here, I'm going to draw a thought bubble.
Exactly.
That's in our head, right? But now I distribute the cosine, and lo and behold,
cosine, and then
it happens.
Exactly. Equals to 1.
And the crowd goes wild. Okay, next one they have on the list. So I'm just going straight down the homework. They want us to say that cosecant squared over 1 plus tangent squared equals cotangent squared. Now, I'm guessing that, well, you can trade this for sines and cosines, but there are identities involving tangent and secant and cosecant and all that. One of them is this one, and I'm going to just remind you. If I have sine squared plus cosine squared equals 1, and I divide both sides by cosine squared, that gives me tangent squared plus 1 equals secant squared. Which screams out that the denominator ought to be
secant squared.
Secant squared. So that's actually a trick if you see it. But I'm going to do this problem as if we didn't notice that.
Okay.
Okay. And I'm going to say cosecant squared, that's
1 over cosine squared.
1 over sine squared.
Oh, sine squared.
It's like backwards.
Oops, yeah, I forgot.
1 over sine squared theta, giant fraction bar, 1 plus...
Sine squared theta over cosine squared theta.
Okay.
Equals cotangent.
Yeah,
squared.
and again, secretly, in our heads, we know that cotangent squared is the reciprocal of tangent, so we know that what we're really shooting for is cosine squared over sine squared.
Yes.
Right? So now, I'm going to draw a dividing line.
Yes.
Between what we were doing and what we're about to do.
Okay, so if we look at the bottom, we probably want a common denominator.
Yes, of course.
So that's like we would say 1 is cosine squared theta over cosine squared theta.
Yes. Okay. So let's do that. cosine squared theta over cosine squared theta, and now we kind of see what's happening.
Yeah, so
because we're going to get
1 over cosine squared theta on the bottom.
right. So the numerator is still 1 over sine squared theta. Right, and you're saying 1 over cosine squared theta because cosine squared plus sine squared is
1, exactly.
Right. So I'm actually going to write this as a...
You go flip it, exactly.
Right. So I'm going to say 1 over cosine squared theta plus sine squared theta, but then I'm going to have times cosine squared theta over 1, because this denominator cosine becomes actually a numerator because it's a denominator.
Yeah.
And this sine squared theta can be written more efficiently out.
Okay, wait. So the 1 over sine squared theta, that one, that was the numerator, and we said that in the bottom we had 1 over cosine squared theta.
Right. So here I'm gonna carry that algebra out, but not with trig stuff. I'll show you essentially what I did. So I did 1 over a divided by, let's call it x plus y over b. What happens? This is a division of fractions.
Yeah.
So it's like 1 over a
times b
times
over
b
x plus y.
over x plus y.
Which is b over a times x plus y.
Right. But I guess I wrote it in the lower right here. If we look at it, I wrote it like this.
Okay, yeah. So
I wrote it like 1 over a times 1 over x plus y times b over 1. I don't know why I did that. But,
okay, but that makes sense.
Okay. So all we're really doing is dividing fractions here. All right. And finally, this thing right here in the middle is a stupid way to write the number 1.
Yes.
Okay, so ultimately we get cosine squared theta over sine squared theta, and now we've arrived at our prediction, right? No, cotangent squared. Our prediction was that this would be the step before we got to the answer, right? And so now we're at the answer.
And the crown goes on.
And I guess you want to draw your line. There's our line. We only took this thing and rewrote it and rewrote it and rewrote it
until we got
to cotangent squared theta. Okay, there's a couple more. One more. There are a few more.
All right, let's do it.
All right, so we're just gonna keep on keeping on.
My stomach's growling.
Okay, so for this last one, I had to start a new page. All right, this one is a mess. Cosine to the 4th theta over 2, and we're asked to make that into 3/8 plus 1/2 cosine theta plus 1/8 cosine 2 theta. Okay. New factoid, new lesson. Whoops. I just crazy zoomed. That is, or those are the cosine squared of theta equals 1 plus cosine 2 theta over 2.
Yeah.
The sine squared version is with a minus. The other way of saying this is to replace or use theta over 2 instead of theta, and take the square root of both sides to say that cosine of theta over 2 is the square root of 1 plus cosine theta over 2. All right. So that's the first thing we're going to do. On the left-hand side is we're going to say this is the square root of 1 plus cosine theta over 2 to the 4th, which is what? 1 plus cosine theta over 2 squared. Right? Let's expand it out. That's going to be 1/4 times 1 plus cosine theta squared, which is 1/4 times 1 plus 2 cosine theta plus cosine squared theta.
Amazing.
Okay. And now we're all set up to use this one.
Yep.
Right? And that's pretty much going to take us to the end. So I'm going to try to keep it still on the screen.
So this was essentially the most difficult problem.
I mean, it's the most intimidating to look at.
Yeah.
And you have to know these half angle and double angle formulas. These guys over here. I mean, you have to know them, and you have to know that, hey, that's what you need here. But this theta over 2 is kind of a big time giveaway that you need to use this thing right there. All right, without further ado, whoops. Uh-oh, that was a mistake.
Yes, it was.
I just deleted everything. Okay, well, no matter. We
remember.
Yeah, we can go back and do it. So we had, let's see if I can remember it. That really irritates me about this program, though. So it was 1/4 of 1 plus 2 cosine theta plus cosine squared theta. Because we said that this was the square root of whatever squared.
Yes.
Right? Okay. Cosine squared theta is itself 1 plus cosine 2 theta over 2. Okay. Let's distribute the 1/4. Okay, and then that's it, because we can split this up into 1/8 plus cosine 2 theta over 8, and then 1/4 plus 1/8 is 3/8. So this is one of those where, like, it must be true. They're asking you to prove it, so it must be true.
Yeah.
So just trust that you'll get there.
Yes.
If you just apply
yourselves and apply the formulas.
Right.
Identities.
So the obstacle is knowing the identities. Okay. And I've had enough of trig identities. Carrying on. The next one is 1 plus cosecant beta. Of course, they have to change the variables as if that makes it somehow harder. Cosecant beta minus, so 1 plus cosecant beta over secant beta minus cotangent beta. And the right-hand side, they want it to be cosine of beta.
Okay, so let's just do it.
Right.
So 1 plus cosecant is don't tell me is 1 over sine of beta all over 1 over cosine beta minus sine beta.
Not sine, cotangent.
Oh, cotangent. Okay, so it's cosine beta over sine beta equals cosine beta.
Well, maybe.
Oh yeah, well that's what. Yeah.
So I think the smartest thing to do is to go ahead and
Yeah, work out the numerator.
divide fractions.
No, I mean if you
Okay, so you want me to work out the numerator?
yeah,
So-
because 1 is just sine beta over sine beta.
Okay, so I'm going to do it like this. I'm dividing by 1 over cosine beta, which means I'm multiplying by cosine beta over 1. And then the numerator is sine beta
Plus 1
plus 1
over sine beta.
over
Or is it?
sine beta. Right?
Mhm.
Okay. And then we're subtracting cosine beta over sine beta. Now this is parenthesized. Right?
Mhm.
Now these fractions are already commonly denominated. Right? So we've got cosine beta times sine beta plus cosine beta, that's distributing the numerator on the left, minus cosine beta, all of that over sine beta. And the crowd is already
Well, they're just starting to cheer.
anticipating the dramatic conclusion. Okay, so this one actually there was no cleverness involved.
No.
This was
It was
just
very straightforward.
follow your nose. All right, next. Oh no. So here we have sine 3u, and the question is this equal to sine u times?
What does that sound? Does an
3?
alien spaceship land outside?
I don't know. I hope it's not coming up on the video.
Yeah.
All right. So we apologize, audience, for the pending takeover of our planet. Okay, so right away here, we know that we've got to use angle sum formulas.
Mm-hmm.
So right in the middle of the video.
This is the sine, cosine, cosine, sine.
Exactly,
cosine.
exactly. So right in the middle of this video, we're going to have to, where should I put it? I'll just zoom out a little bit. We're going to have to sidetrack and introduce a new lesson. Sine A plus B equals sine A cosine B plus cosine A sine B. And then the other one is cosine A plus B is cosine A cosine B minus sine A sine B. Okay, like you said, sine, cosine, cosine, sine, cosine, cosine, minus sine, sine. I don't know why that sticks in my head, but it does.
It has a rhythm.
And so that means we're going to take sine 3u upon making the observation that sine 3u is equal to u plus 2u. We can write this as sine u cosine 2u
yeah.
plus
Sine 2u.
cosine u
Oh, sine of 2u. Okay, got it.
times sine of 2u. And there were those other identities. Cosine 2u is cosine squared u minus sine squared u. And sine 2u is 2 sine u cosine u. Okay. You can memorize these, or you can actually derive them from the angle sum formulas by taking A equals B equals U. Okay, continuing to sort of do nothing but follow our nose, meaning we have no choice here. but to replace 3u with u plus 2u. And we have this memorized, and so we did that. Okay. Cosine 2u, sine 2u. We've got no choice but to use these formulas that we just see. So sine of u cosine squared minus sine squared plus cosine u to sine of u cosine u. And things are looking up because now we have everything in terms of u.
Yeah, that helps.
It helps a lot because everything in our right-hand side is also in terms of u. All right, we can factor the sine u out, which means we're done with that, right?
Yeah.
So we have sine u on the outside, and whatever's on the inside better work out to be exactly the same as 3 minus 4 sine squared u.
Okay, let's just take a look.
So
we already have a 3, because you have that cosine squared u, and you have a plus 2 cosine squared u. So essentially that's 3 cosine squared u minus sine squared u.
okay, so I see where you're going. So, whoops, tried to zoom up. You're saying this,
Yes.
so we have 3 cosine squared u minus sine squared u. And if you look up at our answer here, everything's in terms of sine squared.
Yes.
And it's easy to trade cosine squared for sine
Yeah,
squared.
as you just multiply.
Not multiply. So
it's 1 minus
exactly.
sine squared, or substitute. So, yeah.
Substitute.
But what I meant by multiply is it's 3 times.
So you're ahead of. Okay, so all this is what's happening inside the brackets.
Yes. So it will be 3 minus 4.
And that's pretty much it.
That's it.
Right? So even though this one is intimidating to look at to begin with.
Yeah, just take it one step at a time.
Exactly. There's nothing, as long as you have the identities memorized, you can't get this one wrong.
And if you don't have them memorized, your goose is cooked.
Right. You also need to know these little rules of thumb, which is when I see something like 3u, I'm going to rewrite it as u plus 2u. And then if I know everything here is in terms of sine squared, and I stuck somewhere in the middle with a bunch of cosine squareds running around, it's no big deal to trade cosine squared for sine squared, right?